lecture. So we learn about the alcohol, okay? The physical and chemical properties of alcohol, the nomenclature, right? The preparation of alcohol and also the reaction involved in alcohol, right? Correct? Okay. So for synthesis of alcohol, for preparation of alcohol molecules, what are the methods available? Titration.
Addition.
He's gonna use the mic. Yes. You use the mic.
Okay, cleaner reagent that involve for the reactions for alcohol. But then now we are talking about the preparation of alcohol. Okay, so how can alcohol be prepared? We have elimination reaction from alkene. Is that correct? Not quite.
Just back and I wish you could answer.
Let's go back to the previous lecture, okay?
Apple. Let's see. Really? It's just a matter of
Okay, so for preparation of alcohol, we have addition reaction. Addition reaction of alkene, okay? And SN2 reaction of alkyl halides. And also the formation of primary, secondary, and tertiary alcohol using organometallic reagents. Alright? Okay. Remember the reaction involved. Addition of
See you, Bombaka.
okay. What reaction condition needed for this reaction?
干嘛的？我已经看完了。
Okay. By adding water alone, the reaction will not happen, will not take place. So you need something to activate it. Okay. So you need an acid. Okay. So for SN2 reaction of alkyl halides,
Substitution.
so you need, do you still remember what is SN1 and SN2? Okay, what is the base involved? Basically, you need the NaOH, right? Either a strong base, okay, or other weaker base if it's involved a tertiary carbon, right? Okay, and the formation of primary, secondary, or tertiary alcohol using organometallic reagents. How to make alcohol from reagent planets. Okay, so basically you need, you just need a base to replace the reagent granite and substitute it into the alkene chain. Okay, and how about the reaction that involve alcohol? many reactions are they for alcohol? Okay, we have oxidation and reduction, right? Oxidation of alcohol. How many oxidants are they? And what is the product of oxidation of alcohol? If we oxidize alcohol, OH, the product will be aldehyde or ketone, right? Or even carboxylic acid. Okay, and what is the reagent needed for oxidation to take place? You have three. PCC, okay, CrO3, and also sodium Na2Cr2O7. Do you remember? Oxidation. If it's not remember, if you not remember, no worry, we'll go through in the tutorial later. Okay? And then how about the reduction of alcohol? Sorry. Reactions that involve a reduction in alcohol. What product?
So awesome.
Okay, we have a few reactions that involve in alcohol. Okay, for example, formation of cleavage reagent. Okay, this is to synthesize primary and secondary and tertiary alcohol. Okay. And also we can obtain alcohol from the reduction of aldehyde. Okay, using sodium borohydrate or lithium aluminum hydrate. Okay. Okay. So reactions that involve alcohol formation of alkyl halides. Again, this is a substitution reaction, either SN2 or SN2, SN1 and SN2. And also it can undergo dehydration. Okay. And also it can be oxidized into aldehyde or ketone or even carboxylic acid. Okay. So basically that's it. That's the reactions that involve for alcohol. Okay, there are few four reactions, and also the synthetic method. We have synthesis of alcohol. We have four, right? And we have six. Okay, synthesis using the Grignard reagent, either primary, secondary, or tertiary. Okay, and then the reduction of aldehyde, and also the reduction of ketone. Okay, and we can also use ester into alcohol. Okay. Using three main reducing agents.
虽然 guitar, listen to class, don't play your guitar.
So we have three main reducing agents. Okay, the
Smooth on.
and then sodium borohydrate or lithium aluminum hydrate. Okay, these are the three main reducing agents that can reduce carbonyl into alcohol. Okay, so today we're going through the similar reactions that involve in aldehyde or ketone. Okay, so this is the negative. Okay, we'll go to the nomenclature, physical and chemical properties that involve for aldehyde or ketone or carbonyl group in general. Okay, so we also learned about the synthesis of carbonyl to obtain a carbonyl compound, okay, and also the reactions that involve in carbonyl. Okay, so there are a few classes of carbonyl compounds, which is ketone. Okay, ketone, we have two alkyl groups attached to the carbon. Okay. By the way, carbonyl group is that means a carbon that attached to oxygen. Okay, and the substitute at the site will determine the class of carbonyl. For example, ketone, we have two carbon attached to the C double bond O at the site. Okay, and for aldehyde, we have one carbon attached to the C double bond O, and then another H attached to the C double bond O. Okay, and carboxylic acid also categorized as a carbonyl group, but then we have a C double bond O and OH. Okay, and then acid chloride, C double bond O, and with a halogen at the side. Ester, you're already familiar in the experiment. Okay, something that give you a pleasant flavor. C double bond O and R. Amide, okay, amide is the component in a protein or peptide. We have a C double bond O and NH. Okay.
我想你的时候我就在那边动。
Okay. Carbonyl group is an odorless carbonyl compound. Okay. In general, come with some flavor. For example, we have vanillin. Okay. Can anyone guess what is the smell of vanillin? Yeah, as the name suggests, it smells like vanilla. Actually, that's the main ingredient of vanilla. Okay, we have vanillin, which is a aldehyde group, and then benzaldehyde. It smells like a stone apple. Okay, it is mainly used in personal care products, a fragrance as a fragrance for personal care products, and also we have a cinnamaldehyde. Okay, this is a class of aldehyde. Okay, guess what is the source? Cinnamon. Okay, and the name suggests cinnamon. It gives you the smell of cinnamon. Okay, and acetaldehyde. There's a fruity smell. Okay, something that used in the alcohol, and also formaldehyde. Not all ketone or aldehyde or carbonyl group give you a pleasant flavor. For example, formaldehyde is one of them. It gives you some unpleasant flavor or smell. Used in as a resin in furniture. Okay. Used as an adhesive resin in making furniture to combine the furniture. Give you some unpleasant flavor and toxic to the human body. Okay. And then we have some more complex carbonyl compound, for example, jasmine. Okay, derived from a jasmine tree. It is mainly used in perfume. And also we have this damascus, which is a component in making alcohol or alcoholic beverages. And we have this muscon, mainly used in perfume. Anyone wear perfume? And it's familiar with this smell derived from muscon. It gives you some musky smell, mainly used for male odorant. Okay. So the physical properties of aldehyde ketones are similar to the previous class. For example, alcohol, with the increase of alkyl chain, the boiling point and also melting point also increase. But how about the comparison with other class of compounds? For example, with ethanol. Okay, ethanol aldehyde with 2 carbon. Okay, all of these cars have 2 carbon, but what is the relative melting point for this class of compound? Let's say we are comparing the melting point of ethane, ethanol, and also ethanol. Which class of compound do you think it has the highest melting point or boiling point? Ethane, alcohol, keto, or aldehyde. So we look at the properties later on. Okay. So this is the hybridization of the aldehyde or carbonyl group. Basically, it hybridizes with a carbon to form a double bond. Okay. So yeah, the angle between the C double bond O and also the substituent, whether it's R or H, is 120 degrees. Okay, and then the polarization is towards the oxygen because oxygen have a higher electronegativity as compared to carbon. So the electron will be pulling towards the oxygen and making it making it partial positive on the carbon, partial negative on the oxygen. Okay, and then the comparison of bond length you can see here, ketone and alkene. Ketone we have a slightly shorter bond as compared to alkene because of the polarity, difference of polarity. Okay, the higher disparity in the polarity, the shorter the bond it is because of the difference of polarity. So the attraction between the electropositive carbon and the electronegative oxygen is more closer together as compared to carbon and carbon, which has a less polarity. Okay, and also the energy involved in the formation of C double bond N is always higher than C double bond C. So what do you think the melting point of
I used one, but
alkene with a similar number of carbon? Let's say we are comparing an alkene, ethanol, ethane, ethanol, and also ethanol. Which one do you think it has the higher melting point? Ethanol, why? Ethanol, why? Okay. Anyone with a different answer?
don't get your mic.
Yes. So when we are talking about melting point, right, it always related to is whether the molecule can form an interaction between each other or not. Okay. So in this case, if we are comparing ethane, ethanol, and ethanol, apparently ethanol have a higher melting point or boiling point because it can form a hydrogen bond within itself as compared with the ethanol, which cannot form a hydrogen bond. Okay.
Dr. Alan, you're not showing screen.
Florence，你现在 join 你是中表情。咚 Oh, it's the sound of the message.
Whoever attended attending the online
Boom. Boom.
Sorry about the technical error, class.
刚才 Q 这老师没有。
Give me a minute.
这 sticker 我自己 print 的，每一件衣服上面。
Okay, just now we talked about the melting point, right? Melting point and boiling point. Apparently, alcohol give you the highest melting point among the ethane or ethanol because due to the formation of hydrogen bond. Okay. So hydrogen bonds, as the name suggests, it might come from if a hydrogen donor, okay? And the hydrogen donor must attach to electronegative atom, such as nitrogen, oxygen, or halogen, okay? Because these three classes of atomic group give you the highest disparity in the polarity, okay? So carbon by definition according to the standard, right? So it will not give you any hydrogen bond because the polarity between the carbon and hydrogen is very big. So it cannot form hydrogen bond even though it has the carbon is attached to hydrogen. So in this case for aldehyde group, okay, although aldehyde is attached to a hydrogen atom, so it cannot give the hydrogen bond, cannot form a hydrogen bond within itself. So that's why the melting point or lower boiling point is lower than that of the alcohol. Okay. So in terms of resonance, so the electron can jump over to the electronegative oxygen, give it a negative charge, while the carbon will be in a positive charge. Okay. So but then apparently the C double bond O is relatively more stable than the charged species. Okay. Because this one, the C double bond O, okay, all the atoms fulfill the octet rule. if you have a nucleophile which is a negative in charge, it will always attack on the electropositive carbon. Okay, while the electronegative oxygen will always attack with those which is electron deficient. Okay, so this one we have gone through this now. Gone through this just now. We have a butane, okay, and ethoxyethane, and propanol, acetone, and propane 1O. So all these molecules have 3 carbons or 4 carbons, similar carbons, I mean, but then their boiling point is different. This is apparently due to the characteristic that the polar group can form a hydrogen bond within itself. So, for example, in this case, boiling point of propanol gives you the highest boiling point as compared to the rest. Okay. Yeah, propanol, this one is lesser than acetone because acetone it has a 3 carbon, 1 carbon more than propanol. Okay, but if we are comparing propanol with the same number of carbon, apparently the alcohol group you have a higher boiling point as compared to acetone. Okay. So ketone or aldehydes are more polar, so that they have a higher boiling point than compared to alkane or alkene or ketone. Okay, but then they cannot form hydrogen bond with each other, so they have a lesser boiling point or melting point as compared to the alcohol group. And the solubility of aldehyde or ketone, as expected, they are easily soluble in water because they can form a hydrogen bond with water. Okay. For example, in this case, the oxygen can form a hydrogen bond with water molecule, so that is easily soluble in water. It's a good solvent for alcohol, and the lone pair of electrons on oxygen can accept hydrogen from the water molecule, or from OH or from NH, so they can interact and soluble in alcohol or any. Okay. So most of the acetone and most of the acetone or acetaldehyde are soluble in water because they have a low number of carbon. Okay, but with the increased number of carbon, the solubility becomes lesser and lesser. That's what we learned in the previous lecture for other functional groups. Okay. So the industrial importance for carbonyl group, acetone and methyl ketone are commonly used as a solvent. Okay, can form an formaldehyde, as I mentioned, used as a resin, and also it used in a polymer like a bakelite. Okay, in the making of polymers like, for example, the food, okay, and this one. And we have formalin. Okay, the main ingredient is formaldehyde. Composition of 40% of formaldehyde. Okay, used in the region of for preserve animal. Okay. And because due to the smell, the odor from carbonyl group, they also use as a main ingredient for flavoring or food additive, or even a perfume. Okay. And then this is the reaction for this making of bakelite. Okay, it's a reaction between phenol and methanol. Okay. So the methanol will be entered into the phenol group. Okay, to give you this bakelite polymer. Okay. So here are a few examples of a ketone of aldehyde with the odor. For example, butyraldehyde, it smells like a buttery, okay, and it's used in a margarine or food. And vanillin, the smell of vanilla, okay, it's used in food and perfume. Okay, and spermine, okay, and the S carbon smell like caraway. Do you know why? Carbon appear in two enantiomer, either R and S. Okay, the R smell like a spermine, and S smell like caraway. So do you have any idea why it smells different for different enantiomers? Yes, exactly. Because our receptor have is also chiral, so we can sense different chiral agent with a different odor. Because the receptor react differently with different enantiomer. Okay. So the nomenclature, okay, as previous one, we identify the long chain, identify the carbon with the longest chain. Okay, for example, in this case, okay, yeah, it has two carbon, so we call it for aldehyde. The surface will be Al. Okay, in that case, ethanol. For ketone, the surface will be ONE, on. Okay, but then for ketone, it must attach to two carbon, right? So what is the minimum carbon required for ketone? 3. Okay, so what we call ketone with 3 carbon, propanol. Okay, so the surface end with ONE. Okay, and for aldehyde, the minimum number of carbon required is 1. So we have a formaldehyde. Okay. So we identify the carbon, the longest chain with highest number of carbon, okay, and then put in the numbering based on the presence of functional group. So in this case, carbonyl group. So this is carbon number 1, 2, 3, so on and so forth. Okay. So the IUPAC name for this one is propronol-3-methylheptanate. Okay. Similarly for ketone, okay, the surface is entered with a ONE on, okay, and the number of carbon as I mentioned, the minimum is 3. So the minimum ketone is a propanol. If it's 4 carbon, then we name it as a butanol. Okay. For cyclic ketone, also the same. Okay, you name it based on the number of carbon in the cyclic ring. For example, this is a pentanol. Okay, and then substitute with and numbering the carbon based on the priority. Okay, the one at that, the carbonyl group always regarded as a carbon number 1. Okay, so in this case, this is 3-methyl cyclopentanol. Okay, and then the priority of a functional group. So we name the class of compounds based on this priority. Okay, the carboxylic acid always have the highest priority. Okay, if you have a molecule that consistent with a few functional group, one of them is carboxylic acid, and one of them is a double bond, and one of them is OH in the same molecule. So the nomenclature will always based on this priority. Okay, so the class of compound is regarded as a carboxylic acid. Okay, and followed by aldehyde or alcohol, and then alkane. Okay, alkyl halide have the lowest priority, so we always give the substitute the halogen as a iodo, bromo, or fluoro. Okay, we do not regard it as a functional group. So let's go back to this. Okay, So this example, we have a carbonyl group, okay, and a double bond. Okay, because carbonyl group have a higher priority than double bond, so we cut this molecule as a ketone. Okay, this is called a two-cycle hexanol. Okay. Similar to this ketone, but then we have beside the IUPAC name, we have also a common name. Okay, for example, this one methyl ketone. Okay, so the naming is based on the substitute on the side of the carbonyl group. For example, if we have a methyl group and ethyl group next to carbonyl group, so we call it methyl ketone. Okay, so this one will based on the alphabetically order methyl ketone. Okay, and then the numbering will be based on the Greek number, Greek letters instead of number. For example, the carbon next to this carbonyl group we call alpha, next to it is called beta. So in this case, this is a bromo group attached to a beta carbon, so we call it a beta bromoethyl isopropyl ketone. Okay. And then the types of molecule substitute, we have a different type, 4 types. We have an N-butyl, sec-butyl, isobutyl, and tert-butyl. So you need to differentiate each of the butyl group based on the name. Okay. Okay. So in the previous experiment, we use acetic acid, right? Some of them, some of us do not know what is acetic acid. So acetic acid is a class of compound that have one methyl group. Okay, acetic acid is a class of carboxylic acid. So carboxylic acid, we have a COOH, right? And when there's a acyl in the prefix, like for example acetone, acetic acid, so we know that there's a 1 CH3 next to this functional group. Okay. So for example acetophenol, so we have a 1 phenyl group and then 1 methyl group attached to the carbonyl group. So that's what we call acetyl. Okay, it's a single carbon group. So now, yeah, we'll do some exercise to generate the structure based on this iopentane. Okay. So for chloro-2-pentanone, how many carbon are they? How many carbon are they for chloro-2-pentanone? 5 carbon. Okay. Where is the position of the chloro group? And the ketone group, carbonyl group. So the carbonyl group is reside on carbon number 2, okay, and the chloro group is reside on the carbon number 4. Okay. So everyone get it? Okay. So let's try. Okay. Number 4. What is the IUPAC name for this structure? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon. 2,6 nonano. Okay. 2,6 nonano. Yeah, that's correct. Okay. So next we'll go through the synthesis of aldehyde. Okay. So in the first lecture we learned about the reaction of alcohol, right? So the alcohol can be oxidized into a ketone or aldehyde. Okay. So similar reaction happen here. So it's just a refresher of the first lecture. How do we obtain aldehyde from primary alcohol? We need an oxidizing agent, right? So what are the three oxidizing agents? It's already given here. We have PCC, CrO3, and also Na2Cr2O7. Okay, what is PCC? PCC, what is PCC? Okay, it's a pretinyl chloroformate. Okay, it's this structure. Okay, we have a chromium group attached to the oxygen and one chloro. Okay. And then we have a pretinyl here, which is a positive charge, and this is a negative charge. So this is a PCC. Okay, it's a relatively milder oxidizing agent as compared to CrO3 and Na2Cr2O7. Okay, it can oxidize primary alcohol into the aldehyde. Okay, but then if we have CrO3, okay, it can oxidize alcohol straight away into a carboxylic acid. And so with this Na2Cr2O7 sodium bichromate, okay, it is also a strong oxidizing agent which can oxidize primary alcohol into a carboxylic acid. But then we have, in case we have a secondary alcohol, it will oxidize alcohol into a ketone. So we check out these examples. Okay. So if we have a primary alcohol, with PCC it will be oxidized into aldehyde. Okay. If it's with CrO3, or in this case H2CrO4, it's the same. We call it a Jones reagent. Jones reagent. Okay. It is a strong oxidizing agent which can oxidize primary alcohol into carboxylic acid. And so with this potassium manganate, it's a strong oxidizing agent which can oxidize alcohol into carboxylic acid. Okay? If it's with a secondary alcohol, then all these three oxidizing agents will oxidize secondary alcohol into ketone. Okay? But no reaction will be happen for tertiary alcohol. Okay? So besides oxidation, so we can obtain alcohol by this ozonolysis of alkane. So do you still recall this reaction in alkene? Okay. So ozonolysis, you will form a reaction with this ozone. Basically, it's a free oxygen molecule. Okay, and the product will be a ketone and aldehyde. Okay, depends on whether this one attached to hydrogen or carbon. Okay, if it's attached to carbon, so the product will be ketone, not aldehyde. Okay. And then carbonyl group also can be obtained from this reaction between aromatic ring and alkyl chloride. Okay. This one alkyl chloride C double bond O X. Okay, is more reactive than carboxylic acid because the polarity is much higher than carboxylic acid. we react this with carboxylic acid, no reaction will be happen. Or at least it require a catalyst to make the reaction happen. Okay, so now we'll go for the reaction of aldehyde or ketones. Okay, so as you learned through the previous lecture, okay, so how do we obtain alcohol from reagent cleaner? First of all, we have the alkyl halide, right? We use we obtain a reagent cleaner by reacting alkyl halide with magnesium ether under acidic condition. It gives us a reagent cleaners, okay? And then after that, substitution reaction, replace MgBr with OH group, and then further oxidize it into aldehyde ketone. So it's a 3-step process. Okay. So we can also reduce aldehyde to use primary alcohol, or ketone to use secondary alcohol. Okay. So we'll go through this reaction one by one. So basically, this is a refresher from the previous lecture. Okay. So we have a reagent gradient react with carbonyl group. So it will give us this ionic species, and then under the acidic condition, it will further convert into alcohol. Okay. So this is a reaction that involves with aldehyde or ketone. So it will react with a cleaner reagent. It gives us alcohol. So in this case, cleaner reagent is actually a reducing agent. It will reduce carbonyl group into alcohol. So depends on the type of reagent cleaner, whether it contains a primary or secondary or tertiary carbon. So the outcome will be dependent on the number of carbon present in this reagent cleaner. Okay, for example, if we react with a reagent cleaner with ketone, so it will give us a tertiary alcohol. And then besides using reagent cleaner, you can also use sodium borohydrate or lithium aluminum hydrate. So these three reducing agents can reduce carbonyl group into alcohol. Okay. So for example, you have aldehyde, it will react with sodium borohydrate and also lithium borohydrate to give us alcohol. Okay. With ketone, it will result in a secondary alcohol. Okay. So for ester and carboxylic acid, so these two molecules can only be reduced using lithium aluminum hydrate, but not sodium borohydrate, because lithium aluminum hydrate is a much stronger reducing agent. So it can reduce ester or carboxylic acid into alcohol. Okay. So this is so this is a reverse to what we learned for the oxidizing agent. So oxidizing agent we have three, right? PCC, CrO3, and also Na2Cr2O7. Okay. So CrO3 and also Na2Cr2O7 is a stronger oxidizing agent as compared to PCC. So in this case, we have different reducing agent with different capabilities. Okay. So in this case, sodium borohydrate is much weaker than lithium aluminum hydrate. So only lithium aluminum hydrate can reduce ester or carboxylic acid into alcohol. Okay. So just now we learned about the oxidizing reduction, right? So now we have an just like SN2, SN1 and SN2 in the alkyl halides, okay, in the presence of a nucleophile. So the nucleophile can be added into this electropositive carbon to also give us alcohol, okay, depending on the type of nucleophile. If the nucleophile contains one hydrogen, then the hydrogen atom will be added into the carbonyl group. Okay. So for example, ethanol react with this ethanol. Okay. So it will give us hemiacetal. It is with cyanide group, fresh CN, so it will give us cyanohydrate. Okay. So it can also subject to microphilic addition of alcohol. If we have an alcohol, right? So the OMA group will be added into the carbonyl group as well. Okay, to give us this acetal group with two OR. Okay, so the reaction mechanism is similar to SN1 and SN2. So it just substitute into the carbonyl group itself. Okay. It is if read with an amine, so it will give us a shift base with a C double bond N. Okay. So I'm sure you're already familiar with this reaction through the previous experiment, experiment 1. Okay. You recall experiment 1, what you did in the experiment? You have a Brady reaction, right?
Oh, with him is
Check
avocado.
on the presence of carbonyl group
Oh, but he's talking about Aya's one.
in the reagent. Whether it's you still recall that? So yeah, this is reactions that involve. Yeah, we have besides the Brady test, we have this Cohen test. Okay, addition of silver, which is an oxidizing agent. Okay, to give you carbonyl, give you a carboxylic acid with a silver mirror. Okay. And then you can also add the water into this carbonyl group to give you this germinal diol. Okay. So do you still remember how to differentiate between a germinal and glycinol
Gemini.
in alkene? We learned about the germinal hydrogen, right? And also the glycinol hydrogen.
It's funny shit. It's so funny. I'll be honest, I'll watch 2 minutes.
Okay. Which one do you think is germinal? Germinal is the one that standing on the opposite, okay? And the germinal one, the glycinol is the one that in the same axis. This is a glycinol, and this is a germinal. So in this case, nucleophilic addition of it, which will give you a germinal diol, which is on the opposite position. Okay, and then this is the reaction between ketone and amine group. Give you the shift base, which we call the Brady reaction. This is what you did in the experiment. A reaction between the carbonyl group with the amine group to give you this product, which is a solid product in yellowish in color or orange in color. you a carboxylic acid under acidic condition. Okay. In the presence of KMnO4, which is strong oxidizing agent. Okay. And then we can also synthesize chloroform from methyl ketone. Okay. For example, we have this acetophenol react with in the presence of
Something I've seen before.
halogen, like for example chlorine or bromine.
It's not that good.
So it will give us a
Based on
CH2,
games.
which is a chloroform.
It's based
Okay.
on
This is how chloroform is synthesized. So the same thing for this reaction between ketone and iodine. So it will give us an iodoform. So besides all these reactions, so ketone or aldehyde, they can also react among themselves, self reaction. So in this case, we have an aldo addition. Okay. So because polarity between this carbon and oxygen, right? Okay, because of the polarity of this carbonyl group, so the dipole moment, the electron will be always pulled from this carbon to this oxygen, so making this carbon electron deficient. Okay, and as a result, the carbon will also pull away the electron from the adjacent carbon as well. Okay, so in this case, if we have a CH2 adjacent to this carbonyl group, so the hydrogen here will be slightly acidic because the electron is being pulled away to this carbon. Okay. So in this case, when you have another molecule, carbonyl molecule next to each other, so the oxygen will take away, will attack on this electropositive hydrogen. Okay, so to give you something like this. Okay, so the reaction will happen, and the molecule will undergo rearrangement, give you this molecule. We call it, this is alcohol addition condensation reaction. So the side product will be H2O. Okay. boric acid. Okay. Okay, so the oxygen, right? Will attack on this hydrogen. Okay, so it will form so it will bind to this carbon. So to give you this product, okay, and then this product we arrange so the oxygen, the hydrogen atom will be taken away by another oxygen approaching to this oxygen. Okay, so it gives you a resonance. So the double bond will be formed in this structure. Okay, so we call this aldol condensation. Okay. So the double bond form next to this carbonyl group. Okay. So can you foresee how the reaction happen again? Okay. So oxygen will attack with this property carbon. Okay. So give you something like this.
What do you think he's playing?
So we bind connect to this carbon. Okay. With a OH group. Okay, and then the OH group will be taken away by another oxygen. So it will give you a resonance. Okay, so the end product will be enol. Okay, it's a condensation product
Oh, it's like valves for a
of this
reason.
reaction. Okay, so yeah.
Oh, they,
So this hydrogen atom, okay, will be removed. Give a
it's a fake.
side product, which is a water molecule. So condensation, the side product will be always have a water molecule. So this one, there's a question in the tutorial, so I'll explain more details in the tutorial session, how the reaction happen for this. Okay?
The gayest guest ever. 他一岁来了，我进去找他。What's wrong with him?
Yeah, let's recap for this lecture. Okay? So we learned about the chemical and physical properties of ketone, aldehyde, carbonyl. Okay? And then we learned about the preparation method for carbonyl and also the synthesis. Okay? So for the preparation of ketone, what are the methods available? It can oxidize alcohol, right? Okay. What is the oxidizing agent? Alcohol.
Why am I muted? What the fuck?
Yes, correct. So there are three strong oxidizing agents involved for the reaction of alcohol. Right? Alcohol give you a ketone or aldehyde. Okay. And then also we have reducing agents. Okay. What are the reducing agents available?
It is.
Yes. Sodium borohydrate, NaBH4, and also lithium hydride. So those reducing agents will reduce ketone or aldehyde into alcohol. Okay. So and then there are also reactions that involve for this
Hungry for chicken.
yeah, ketone. Okay. So is there any questions? Do you need to recap? You need to recap for this lecture. So we have about 45 minutes. Do you have any questions?
Yeah, same.
So there will be a tutorial session on this.
That's not happening this week.
Thursday, Friday. So we'll discuss about the formation of ketone and
Miscalculation.
so besides that, do you have any questions?
It's not a miscalculation. It's just a calculation. Oh shit! 这睡了两个。Go for one chicken. 哦哦哦。But this Saturday we have to come to school, right? This Saturday, right? We have to come to school.
Unfortunately, yes.
But this Wednesday don't have class, is it?
This whole week don't have
Oh. You never ask.
one day. My wife said you happy baby. Not me. But remember to like my